Family Caesalpiniaceae. I am Dr. Mamta N, Associate Professor working in Government First Grade College, Vijayanagar, Bangalore, which comes under Bangalore University. Family Caesalpiniaceae. This family includes around 152 genera, 2,800 species found in tropical and subtropical regions, and it is represented by 23 genera and 80 species in India. The common plants include Saraka ashoka, Tamarindus indicus, Bauhinia, Caesalpinia. Classification. According to Engler and Prondtl, it comes under class Dicotyledonnae, order Rosalus, family Fabaceae, subfamily Caesalpinioideae. Coming to the vegetative characters. Habit. Most of them are trees, for example, Tamarindus indicus, shrubs like Parkinsonia, herbs like Cassia tora, and the root system is a taproot. Stem. Stem is usually aerial, erect, woody, herbaceous, armed with prickles, and in some cases, tendrils may be present. Leaves. Leaves are alternate, stipulate, and the leaf base is pulvinate. Unipinnately compound, as in case of cassia, or bipinnately compound, as in case of tamarindus, or simple and bilobed in Bauhinia, and stipules are modified into spines in case of Parkinsonia. Inflorescence is usually a raceme or a spike, rarely corymb or solitary. Flowers are bracteate, pedicellate, complete, zygomorphic, bisexual, pentamerous, hypogynous or perigynous. Calyx is made up of calyx, sepals 5, free or connated base, or form a short or a long tube, and the odd sepal is anterior in position. And calyx is petaloid in case of Saraka. And in case of Tamarindus indicus, the upper two sepals are united. And estivation is usually valvate or imbricate. Corolla. Petals are usually 5, alternating with sepals, polypetalous, and estivation is ascendingly imbricate, and usually petals are unequally sized. And ratio. Usually 10 free stamens are arranged in 2 alternate whorls of 5 each, that is diplostaminous condition. And all the 10 are perfect in case of Caesalpinia, and it can be 5 to 7 in case of Cassia, 3 in case of Tamarindus, and the anthers are dithecous, intros, dehisce longitudinally in Delonix regia, that is Gulmohar, and Parkinsonia, or terminal pores, as in case of Cassia. Gynoecium. Ovary superior, monocarpellary, unilocular, with two alternate anatropous or campylotropous ovule on marginal placentation. Style is simple, stigma capitate. Fruit, a legume, sometimes indehiscent, often winged. And seeds may be endospermic or non-endospermic. Some of the plants of economic importance are: some of the plants yield dyes and tannins. For example, the bark of Bauhinia species, namely Bauhinia malabarica, Bauhinia racemosa, Bauhinia purpurea, Caesalpinia, yield tannins of commercial importance. The heartwood of Hematoxylon capecianum yield a dye known as hematoxylin, whereas the heartwood of Caesalpinia sappan provide red-orange dye used for dyeing cotton, silk, etc. And some of them are edible, like the flower buds of Bauhinia variegata and Bauhinia purpurea. And the fruits of Tamarindus are edible. Medicine. Fruits of Cassia fistula are used as laxative. Leaves, in case of Caesalpinia sophera, are used externally for ringworm, and decoction is used for bronchitis. And leaves and bark of Cassia glauca are beneficial for diabetes. Some of the ornamental plants include Delonix regia, Saraca suoca, Boinia racemosa, Boinia variegata, Boinia purpurea, species of cassia like Cassia fistula, Cassia nodosa, Cassia marginata, Parkinsonia aculeata, Caesalpinia pichilima. Other plants of economic importance. Gum of commercial importance is obtained from Boinia racemosa, and seed of Ceratonia siliqua yield carob gum used for sizing, fabric and printing, tanning and paper industry. Hardwickia binata, the timber is used for making cartwheels, plows, beams of bridges. This picture clearly shows the twig of Cassia fistula, as a flower, then parts of a flower, that is stamen, gynecium, tears of ovary, and the floral diagram of Cassia fistula. Coming to the next subfamily, that is Mimosoideae. This family includes 56 genera and 2,800 species, mostly tropical and subtropical in distribution, and about 15 genera and 75 species are reported from India. Some genera with species are Acacia, around 750 species, Mimosa, 450 species, Albizia, around 100 species, and Prosopis, around 40 species. Classification. According to Engler and Prontel, it belongs to class Dicotyledone, order Rosilus, family Fabaceae, subfamily Mimosoideae. Vegetative characters. Coming to the first one, that is a habit. Most of them are trees, like acacia, albizia, and some are shrubs and herbs and even woody climbers. That is, liana are nothing but a woody climbers. Example is Enteda. The root system is a taproot. Stem is aerial, erect, herbaceous, climbing, or woody. Leaves are bipinnate, alternate, stipulate. In some species of acacia, the stipules are modified into thorns. In many species of Australian acacia, the leaves are represented by phyllodes. Sensitive and possess sleep movement in Mimosa and Neptunia. Inflorescence. Inflorescence is a globose head, as in case of Mimosa pudica, acacia species, or it can be racemose or spicate, prosopis, or in Dicrostachys, the spikes are dimorphic. The flowers in the upper half of the spike are perfect, and those in the lower half are neutral, bearing stamens. Flowers are bracteate, sessile, complete, actinomorphic, hypogynous, bisexual. And it can be unisexual or polygamous, as in case of Dicrostachys. Mostly pentamerous, and sometimes it can be 3, 4, or 6 meters, as in case of Mimosa. Calyx. 4 to 5 sepals are present, which are united into a short tube, and the estivation is valvate or rarely imbricate, as in case of Parkia. Corolla. Number of petals is 4 to 5, which are subconate at the base or form a short tube, as in case of Acacia, Albizia, or it can be free, as in case of Parkia, and the estivation is valvate. Stem and ratio. Numerous stamens are present, which are free, as in case of Acacia, and in Albizia and Pithecollobium, indefinite stamens are monadelphous at the base. That is, they are fused at the base, only at the basal region. Filaments are long, filiform, and often exerted. Anthers are dithecous, intrors, versatile, and dehisce longitudinally. Gynecium. Ovary is superior, monocarpillary, unilocular, with many ovules on marginal placentation. Style single, and stigma is capitate. Fruit is a lumentum, as in case of Mimosa acacia, and the seeds are non-endospermic. Coming to the plants of economic importance. Some of the ornamental plants are Mimosa pudica, Acacia, Albizia, Pitheciliobium, and some plants yield tannins. That is, the bark of Acacia nilotica, Acacia catechu are used in tanning of animal skins. Catechu or kata, hardwood of Acacia catechu is used for coloring khaki clothes. Gum arabica is used in medicine, textile industry, and the timber from species of albizia and acacia are used as timber. Many species of acacia yield timber which is used for variety of purposes like making agricultural implements, cart wheels, etc. Xylea xylocarpa provides timber for railway sleepers and agricultural implements. And some of them are edible also, like stem tips of Neptunia are eaten as pot herbs and pods are used as vegetables. The diagnostic or the salient features of this subfamily is the plants are usually trees or shrubs, rarely herbs, leaves are bipinnately compound, and stipules may be present. Some genera are thorns in some genera. Flowers are tetra or pentamerous, actinomorphic, hypogynous, often fused petals. Stamens are 10 or many. Filaments are exerted, that is, they extend beyond the petals, and fruit is a lumen. This is the twig of Mimosa pudica, fruit, which is a lumentum, then the stamens, gynoecium, and the floral diagram of Mimosa pudica.